All right, we're going to begin chapter 2, section 2, where we're going to introduce functions. Now, functions we've seen before in Algebra 1. This was a huge topic in Algebra 1. But essentially what a function is it relates some x value, or we might have called that an input, with some y value, right, an output, right? So essentially a function is a rule that when you plug in some x value, right, so I'm plugging this x value in to my function, right, so this goes in here, right, we're going to say that this is our little function rule right here. It does whatever process it needs to with that x, and then it spits out a value y, all right? So it relates an x value with a y value, all right? Now this is probably one of the more widely applied things in math, right? So pretty much anything in the real world can be modeled with a function, right? And you guys have seen before in science, right, discussing like independent and dependent variables, right? There's like a cause and effect of something, right? So something goes through some sort of process, and then something happens as a result from it, all right? So there's like real world examples to functions, which we maybe won't talk about in this class, right? The point of this class is for it to be purely mathematical, right? And we'll do some real world applications where necessary, but this lesson is just going to be about the mathematical part of the mathematical applications of functions. All right. So like we said before, it relates one x value with one y value, meaning if you have one singular x value or one input, it can't spit out two different things, right? I can only expect one value to be put in and one value to be put out, all right? So to determine if a set represents a function, you're just trying to see if any x values repeat, all right? So if you look at number 1, all I want to look at is the x values. So my x values here are 1, -2, and 3. All right, nothing repeats, so I'm going to say that this is a function. Right, and it doesn't ask us to explain, but just for the sake of our notes, I'm going to explain this. Right, it's a function because no x value repeats. Right, it cannot be a function if one x value gets you two different y values, right? But if you look at number 2, I have an x value of 1, 1, 1, and 2, right? This one would not be a function, right? Not a function. All right, and again, I'll give a short little explanation, right? X equals 1 is a repeated value. All right. So because one input gets two different outputs, or in this case, 3 different outputs, right? We get 1, 2, and 3 as our outputs. This one would not be a function, all right? Now, 3 and 4 are what we call mapping diagrams, right? So it's a map of where an x value goes to a certain y value, right? But you can think of these just like ordered pairs, right? So if x is 1, and that is mapped to 2, right? That's an ordered pair of 1, comma 2. All right, same thing with the next one, right? If -2 is mapped to 4, think of this as -2, comma 4. And if 3 is mapped to 1, think of this as an x value of 3, y value of 1. All right, and if you're looking at it like this, you can see clearly that no x value repeats. All right, I have 1, -2, and 3, right? So this one would be a function. And then again, just because no x value repeats. No x value repeats. All right, so we can do the same thing with the next one. All right, if 4 goes to 1, right, that represents an ordered pair of 4, comma 1. If -2 goes to 1, that represents an ordered pair -2, 1. But -2 also goes to 0, right? So that's a -2, comma 0. Right? And maybe you didn't even have to write the ordered pairs for you to be able to see that. But from here, you can see that this -2 it goes to two different y values, so this one would not be a function. So I'm going to say this is not a function. All right, why? Because x equals -2 repeats. Or it goes to two different y values. You can also say that. All right. Now, let's say you don't have just discrete data like that. That's given to you as like one x value with a y value, things like that. Maybe you see it on a graph. All right. I don't believe this set of notes has a graph, but on a graph you can tell if it's a function or not if it passes the vertical line test. Right. So something like a straight line, right, would pass the vertical line test because I can draw a vertical line anywhere and it would touch the line exactly once, right? But for example, something like a circle. A circle is a kind of relation, right? It relates x values with y values, but it's not a function. All right, because if I draw this vertical line, you guys can see, right, it's touching here and it's touching here. All right, and I'll even draw that with a solid line. All right, touches here, touches here. All right, so that's from a graph. The way to tell with an equation is if you see y raised to an even power, or you see that y is in an absolute value, then it is not a function, right? That's really the only restrictions that we have. Just because when you square something, right, two different things that you square can get the same value, right? So something like 2 squared and -2 squared, right? I don't want to relate those to the same x value, right? The same thing with the absolute value, right? Absolute value of 2 and the absolute value of -2 get the exact same number. So I don't want two different y values to relate to one x value, right? So that's why those are our only restrictions. Everything else is fine. All right? So just by looking at this page, we can do this very quickly, right? Look at all four of these equations and you want to tell whether y is a function of x, right? So you might see all sorts of craziness, right? On this page, it looks pretty normal, right? Our equations. But sometimes they look kind of funky, right? And you might see in your homework, you might see in our quiz review, right? But the only thing that you're looking for, again, is if you have y raised to an even power. So if you look at number 1, there's nothing wrong with y, all right? Number 2, there is y raised to an even power. Number 3, y is also raised to an even power. And number 4, nothing is wrong with that y, right? It's raised to no power, right? So I would say that 2 and 3 are not functions. Not functions because y is raised to an even power. Y is raised to an even power. Right? The other thing was also the absolute value. So let's just say, for example, number 1, let's say it was x squared plus the absolute value of y, right? Then that wouldn't be a function because y is in an absolute value, right? So that one wouldn't be a function, all right? But really, those are the only restrictions that we're looking for. If on this bottom one, number 4, I have y raised to the 8th power, all right? Can't be a function because 8 is an even number, all right? But so far, this is all we have for this page, right? 2 and 3 are not functions, the other ones are. All right? To evaluate a function, all you really have to do is to plug in the number or expression everywhere that you see the x. So trying some of these, right? Evaluate the function given f of x is x squared plus 3x plus 1, and I want to find f of 0. Right, so f of 0, that just means I'm going to take this 0 and I'm going to replace it everywhere I see an x in f of x, which is going to be this x squared and this 3x. All right, so that's really the only thing that we're changing. This is going to be a 0 squared plus 3x, 3 times 0 plus 1. All right, and I can even highlight where that happens, right? I have a 0, and that's going to go in this x and this x. All right, and then you just evaluate this, right? 0 squared, hang on. 0 squared is 0, plus 3 times 0 is also 0, plus 1, which is just 1. So f of 0 is 1. All right, should be super easy. All right, and you can do the exact same thing with the next one, right? If I have f of 1, I'm going to plug in 1 everywhere that I see an x. So right there and right there. So this is going to get us 1 squared plus 3 times 1 plus 1. And so this is going to get me 1 plus 3 plus 1, So 5. So f of 1 is 5. Right? I can do the exact same thing with negative 1, right? I'm going to take that negative 1 and then plug it everywhere that I see the x. So there and there. So this is going to get me negative 1 squared plus 3 times negative 1 plus 1. So it's going to get me a 1 minus 3 plus 1, which is going to get you negative 1. So f of negative 1 is negative 1. All right, with g, we can do the same thing, right? So if I have g of 2, I'm going to plug in a 2 everywhere that I see an x in g of x. So right there and right there. All right, so this is going to get me a negative 2 squared plus 4 times 2 plus 1. All right, and so this is going to get me a negative 4 plus 8 plus 1, which when you add that all together, you get 5. All right. Now, if I have anything that's not a number, like g of t, all we have to do is we're still going to do the same thing. It's just not going to get us a number out of it, right? So I'm going to take that t, and I'm going to replace every x that I see with a t, right? So this is going to get me a negative t squared plus 4t plus 1. There's nothing more I can do to that, so I'm going to leave it alone. All right, so it's just going to look like that. All right. Now, if I have a bigger expression, same exact thing, right? If I have g of x plus 2, all I have to do is replace the x that I see with an x plus 2. So this is going to be a negative x plus 2 squared plus 4 times x plus 2 plus 1. Right? Again, all I'm doing is I'm replacing that x that I see in this function, right, with an x plus 2. And so this is about as much work as you'll have to do in these kinds of problems. And so all we really have to do here is we're going to write this twice and FOIL it. So this is going to be an x plus 2 times an x plus 2. Right? We can distribute that 4, and then we get a 4x plus 8 plus that 1 on the outside. Right? And then when you FOIL this, you end up with the negative, and then in parentheses x squared plus 4x plus 4. And then plus 4x plus 8 plus 1 is 9. And then you can just distribute that negative, simplify, and then combine like terms. So we get a negative x squared minus 4x minus 4 plus 4x plus 9. And then negative 4x and 4x cancel out. And then negative 4 and 9 are like terms, so I get a negative x squared plus 9. All right? So again, that's about as much work as we have to do, but hopefully it wasn't hard work, right? Hopefully once we see that we plug in the x plus 2, right, shouldn't be extremely, extremely difficult. All right, so this page is the exact same thing. I just have another function, right? So if I have h of x is 10 minus 3x squared, I'm going to do the same thing. So we're going to do h of 2 is going to get you a 10 minus 3 times 2 squared. So this is going to get me a 10 minus 3 times 4. So 10 minus 12, which is negative 2. All right, and I can do the same thing with h of negative 2, right? This is going to be a 10 minus 3 times negative 2 squared. All right, so 10 minus 3 times 4. So it's going to get you 10 minus 12, which is also negative 2. All right, and you guys are going to learn in the next lesson that there's actually something special about this. If I plugged in a number, so 2, and the negative of that number, so negative 2, and we got the exact same thing, then we call this an even function. Right? If you had opposites, so let's say you had a negative 2 and then a positive 2, that would be called an odd function. Right? You don't need to know that for the sake of this lesson, but just so that you guys are aware, we will see even and odd functions in the next lesson. All right, so that's just something good to keep in mind. All right, and then lastly, h of x minus 1, I'm going to replace this x that I see here with an x minus 1. Right, so this is going to get me a 10 minus 3 times x minus 1 squared. And then we just simplify this as much as we can. So we get a 10 minus 3 times x minus 1 times x minus 1. And then this is something that we're going to have to FOIL. And so we end up with a 10 minus 3 times x squared minus 2x plus 1. And then we distribute that negative 3. And then we go to 10 minus 3x squared plus 6x minus 3. And then combine like terms, so 10 minus 3 is going to get you 7. So I get a negative 3x squared plus 6x plus 7. Right? And so this is h of x minus 1. All right, the very last thing that we're going to discuss in this lesson, some of you maybe seen this in Algebra 1, some of you maybe have not, this might be completely new for some of you, but we're going to evaluate piecewise functions, right? So what you're looking at here, this is one singular function. It's just two different equations for certain x values, right? So if you want to interpret this, you can really say that this is two functions, right? I would not write this every single time, but just so that you guys are aware, this is the same as f of x is equal to x squared minus 1 when x is less than 0. And then I have another function, right? I can say, or f of x is equal to x minus 1 when x is greater than or equal to 0. Right? So there's certain x values that you're going to plug into this function, right? So this one right here, or there's certain x values that you're going to plug into this function, or this one right here, right? So what we have to do is first we're going to look in this little bit right here, right? We're going to look in our restrictions on our x value. So what I'm going to do is I'm going to first look at letter A, right? So f of negative 1. You're going to ask yourself first, is negative 1 less than 0, or is it greater than or equal to 0? Right? Hopefully that's a question that we all know the answer to, right? So negative 1 is going to be less than 0, right? So if it's less than 0, I'm going to plug it into this first one. I don't even need to look at this second one for now, right? I'm just going to plug it into the first equation, which is going to be a negative 1 squared minus 1. And so that's going to get me a 1 minus 1. So f of negative 1 is going to be 0, right? Do not plug it into the second equation. You don't have to do that. If x is less than 0, all you have to do is plug it into the first one, ignore the second one. Now, so you might be asking, well, what's the point of having the second one then? Well, it's because some values are not going to be less than 0. So if I have f of 0, 0, you want to ask yourself, is 0 less than 0, or is 0 greater than or equal to 0? And then hopefully, again, we know the answer to that. 0 is greater than or equal to 0, so it's got to go in the second one. We're not going to look at the first one at all. We're just going to look at the second one. All right, so this is going to be 0 minus 1, which is negative 1. All right, and then that's, in general, the process that we're going to do. So I'm going to look at f of 1. Again, ask yourself, is 1 less than 0, or is 1 greater than or equal to 0? Right, and it's greater than or equal to 0, so I'm going to plug it into the second one. So 1 minus 1, so f of 1 is going to get you 0. All right, and then I added a couple more problems in here just so that you guys can get a little bit more comfortable with it. Right, if I had f of negative 5, again, ask yourself, is negative 5 less than 0, or is it greater than or equal to 0? It's less than 0, so I'm going to plug it into this first one, ignore the second one. So this is going to be a negative 5 squared minus 1, so 25 minus 1, so 24. All right, so I have f of negative 5 is 24. All right, 5 halves, f of 5 over 2. Is that less than 0, or is it greater than or equal to? Well, it's greater than or equal to, so I'm going to plug it into the first one, ignore the second one. All right, so this is going to get you 5 over 2 minus 1. All right, fraction and a whole number, all you have to do is get a common denominator, so I'm going to do over 1 times 2 times 2, and this is going to get me 5 over 2 minus 2 over 2, so I get 3 over 2. All right, and then lastly, f of 4. All right, ask yourself, is 4 bigger than or equal to 0, or is it less than 0, right? It's bigger than or equal to, so it's going to go in the second one. All right, so I'm going to do 4 minus 1, which is 3. All right, for the sake of this class, the only thing that you have to do with piecewise functions is evaluate them, right? We're going to skip the graphing part of it. That's in a later section, right? All you have to do is just know how to do everything that's on this page. That's all we would ever ask you to do, right? And then that concludes this lesson.